Okay, I'm very sorry I have to be out again. My husband is actually admitted to the hospital this time so that they can take the time to figure out what's actually wrong with him. So please, thank you for behaving for the sub and getting your stuff done, but just so that you guys can move on and not be stuck waiting for me to get back. So your homework last night, the online form, if you got it correct, which of the following are true about a period? It's the time it takes for one back and forth motion. It's measured in seconds, and you can calculate it by taking time over cycles. Okay? If you think about it, if you do time on top, your units will end up being seconds. So that works out perfectly. And then we'll deal mostly with period today. We'll talk about frequency more as we continue working with waves. Frequency, on the other hand, is pretty much all the opposite choices. It's the number of back and forth motions per second. Okay, it's measured in 1 seconds or hertz. Okay, if you think about it, per second is /seconds. Okay, so hertz measures per second. And then to get that, you do cycles over time so that you get number of cycles per second. Okay, very easy thing to accidentally flip, so make sure you get that straight in your head. True or false, frequency and period are inverses of each other. That is true. That is why frequency equals 1/period, or period equals 1/frequency. And then, what is the period of a pendulum that swings back and forth 30 times in 10 seconds? So again, if you go by your rules, it's got to be time on top for period. That should be the 0.33 seconds, because the correct units are seconds. Okay, and then what is the frequency of a pendulum that swings back and forth 30 times in 10 seconds? Go by the rule where this time goes on the bottom. So 30 divided by 10 would be 3 hertz. If you chose all of those, you got it right. Okay, I have to go fill out my name. But to do your lab today, what I want you to do is, you can pause this so that you can get logged into the Chromebooks. Okay, so get logged in. And what I want you to do is, just in the search, when you open the browser in the search area, type in FET pendulum. And then it should be the first one that pops up. Pendulum Lab, motion, pendulum, simple, FET. Alright, you can hit run now. And it should look like this. Oops, sorry. So in your lab, you're going to be observing how length affects the period of a pendulum, so you can change length of this bar. Okay, you're going to be observing how mass can affect the period of a pendulum. You can change mass here. Okay, and you're going to be observing how angle affects the period of a pendulum. Now keep in mind, I don't want you going bigger than 25 degrees when you get to the angle. For the length and the mass, you can use the whole range that's available, but keep under 25 for the angle. Okay? So to do this, you will want the other tools button checked, because this is going to give you a timer. Okay? And good lab technique, you only test one thing at a time. Okay, so identify which independent variable you're going to start with. Say you do length, you're going to make sure that you leave your mass button alone, and you're going to make sure that you always pull to the same angle. Okay, so if you always want to pull to 25, make sure for all 5 different lengths you always pull to that 25-degree angle. So if you let go, it starts swinging. Now, if you remember from the video, a period of a pendulum is one complete back and forth motion. So if you think about it, starting at the right blue mark, so start, end. That was 1 period, 1 cycle. Okay? Or I guess to measure period, you just then add your timer. Now, based on your data, you're actually going to measure 10 cycles. Because are you going to be perfect at starting it at that blue line every single time? Probably not. So if you measure for 10 cycles, then you have error in the first cycle and the last cycle, but all the rest are error-free. So that reduces your error. Okay? So you'll start it as close to one of the blue dots as you can, and then you'll count every time it returns to that blue dot till you get to 10. Okay, so say there's 1, 2, 3, and so forth. Okay? Once you have that, record your time. To get down to 1 cycle, I hope you know to divide by 10. Okay? And that's how you do this lab, the first part of the lab. So do that 5 times for different lengths, 5 times for different masses, and 5 times for different angles. And then you'll be able to determine which ones actually create a difference in the period and which ones don't. Okay? And as far as the very, very last column, period, think about what the definition of a period is. And hopefully that will indicate to you what that should match. For part 2 of the lab, you see this crazy equation written up at the top of the page. You're going to be using the pendulum to test our gravity constant, 9.81 meters per second squared. So you'll run this very similarly to like you did with the length portion of the first part of the lab, with the given lengths in the data table. And then you will use this equation that shows the relationship between period and length to determine what gravity is on Earth. Okay? So to rearrange this so that you're solving for gravity, especially since you're going to have to do this calculation multiple times, it's easier if you have it rearranged rather than plugging it in and rearranging the numbers every time. So you have t equals 2 pi times the square root of length over gravity. Move the 2 pi over by dividing. And then to get rid of the square root, you square both sides. Okay? And then after doing that squaring, you have t over 2 pi. That whole thing is squared equals L over G. And if we move L now, then we're going to be solving for 1 over G. So what I've done is I have done an inverse on both sides, which means I've just flipped the fraction on both sides. If I flip the fraction on one side, I can flip the fraction on the other side. So now I have 2 pi over t, and then all of that squared equals G over L. Now it's really easy to just move L, and I'm solving for G. So if you plug it in this way, and be really careful about making sure that you're doing 2 pi over t squared, okay? Either put it in parentheses or do 6.28 divided by your period and then square it and multiply by length, because this will be the one area if you make a mistake where it happens. If you're getting numbers that are way off from 9.8, like you're getting hundreds or you're getting decimals, something's going wrong with your calculation. You should get pretty good data, especially because this is a lab simulation. But that's the whole lab, and then I will hopefully be back in class on Friday, and see you then.